So now, after 9.6, we have 9.7. 9.7. And here we will discuss one more type of series, which is called power series. Power series. So first of all, means you should know about that, how the power series looks like basically. Do you have any idea that power series it looks like what was the format of the power series? Okay, actually, before this, section, we have, in our calculation, we have the variable n. Okay, power series has this format. Please, power series may be like that: sigma n is equal to zero to infinity. For example, it is x raised to power. Yeah, it's yes. Okay. So the power series looks like that, or its power series can be looks like that. X C. Okay, so these both of the series are basically called power series. But my question is then, how do you know that you have the power series in your question?
You have something flexible.
Yeah.
Open.
Before that, before 9.7, we did not say any power series, say it's a series. Okay. And then we have dramatic series, P series, ordinary series, different series. But this time we say that is a power series. So how do we know that, or how the question is given to you, it is power series basically?
Under the bonus, there's the plus of
Any other answer? How do you identify this is power series? Huh? It is exponent. Actually, if you observe all the questions before 9.7, do not find any basically x in your question. Only n. Now you have n and also x. So whenever you will observe that in your question, x is involved, it means this is power series. So you treat this series as a power series because it has its own requirement basically. Okay?
X is not constant.
No, not constant. It's a function basically. So you have now two functions together with two variables x and n. That's why this is called power series. Please, whenever you have x involved in your calculation, so basically it is called power series. Okay, so this is the first thing. which you have to basically identify. Okay. So as you observe that in my question is x is involved, so it will be a power series. Okay, good. Now, I have given two, both of them are power series because here you can observe x, here you can observe x. Okay, but can you mix how you differentiate with the difference between here and here? How they're different? What is the difference between this power series and that power series? There is no
Function.
Yeah, any other answer, please? How you differentiate means how you can find some difference between this power series and that power. Can you explain something about that? That's one. Okay. Actually, this power series is centered about C. This power series centered about point C. And this power series is centered about zero. Yeah, because there is no point here. So whenever you have a power series, basically, so this is centered now about zero. Like, and this power series basically centered about the point C, whatever you have here, okay? So this is centered about that point. So you understand, please? The difference between them? Okay. Right.
So what did you write? Content?
Centered about zero. And this power C is centered about this point C. Now, I will basically just show you the 9.7 exercise, and I ask you that the power series is centered about what? So please take a look. This is basically 9.7 exercise. And there are some series which are available here. For example, okay, first of all, if you look at the question number 2, is it power series number 2? How do you know?
Since we have X and
Because- Because x is involved. So whenever x is involved in your question, understood is power series. Okay. My next question. This power series is centered about what?
centered about C. Negative.
Five.
Oh, no,
Five.
Yes, please.
That's one. Five.
Centered about what?
Negative one.
Negative line. Yes, because I told you the general form, it is x minus basically. Okay. So solve for x. That's it. Just solve for x. It gives you the point where about it's centered. Okay. Okay. Question number 4. Is it power series?
Yes.
But one question.
Yes.
Is it power series?
Yes.
Okay. Centered about what?
Two. Two.
Two.
Three.
2 or 3. Yeah. This power series is basically centered about 2 by 3. So you have to solve for x.
How can you know what's it centered about? How can you
Solve for x, please. 3x minus 3 equal to 0
you divide
and get x value.
two of it?
Yeah, okay. Okay. Question number 5. Is that power series? Number 5.
Yes.
How do you know? Yes.
Because, yeah.
Because x is involved. Yes. So center about what?
Two.
2. Which was 6.
No, zero.
It's not.
Zero, centered about zero.
Sorry. Yes, it is power series because you have x and it's about 0. Absolutely right. So this power series is centered about 0. Okay, good. So do you know how to check? Is it power series and it is centered about what?
Yes.
Okay, good. Now, as I told you, means the power series is slightly different from the other series which we discussed before. And the reason is that because you have now 2 variables n and x, okay? Now look at the question in 9.7 basically. If you look at the question in 9.7, what is the requirement? If you look at it, please. in all these 1 to 36 question, it has basically three parts, A, B, and C, understand? And in exam, we give you questions same like that. The 9.7 is that question where basically three parts and each part has marks. Basically, each part has two. So marks. So becomes how many marks?
8.
Six. So this question basically comes with 6 because we need part A, part B, and part C. Okay. If you look at here in part A, what we need?
Find the series radius and
Radius and
interval.
interval of what? Convergence. One thing is very clear. We need interval of what?
Convergence.
Convergence. We are not interested in the divergence part. No, we only have to check from which x value to which x value the series converges. Understand? It's our first requirement. Actually, in part A, you need two things. Interval of convergence, and what is that? Radius and interval of convergence means you need radius of convergence and interval of convergence. Basically, in part A, two things are required. Mathematically, we use the notation capital R, which is radius of convergence, and capital I, which is called interval of convergence. So we need capital R and capital I. Means radius of convergence and interval of convergence. Please, these two things are required only for what? Only convergence part. Which part? Convergence. Yes, please. We're not interested in the divergence part. We are not interested that on which part is divergent. We only have to check from which point, from which x value to until which x value the series converges. Okay. In part B, oh, sorry. In part A is asking three things. Number one, the radius of convergence. Number two, interval of convergence. And number three, for what values of x the series converges what? Absolutely and conditionally. So basically, these are three things which are required. Number one, we need interval of convergence. Number two, we need radius of convergence. And number three, we have to check which x values the series converges absolutely and conditionally. In fact, in exam, we do not ask about absolutely convergence. We only ask about conditionally convergence. Yes. Okay. So we basically asked about that on which x values the series converges conditionally. Okay. So first of all, I should explain to you how you calculate interval of convergence, how to calculate radius of convergence. Understand? Then we discuss about how we check that the series converges conditionally. Okay, on which values of x, on which x values the series converges conditionally. So one big one we have to answer. Same like this question you get in exam. Part A, you need interval of convergence, means capital I. Part B, you need radius of convergence, means capital R. And part C, it will ask you on which x values series converges conditionally. Okay?
You only get one question from 9.7.
Yeah, only one because I like the question in three parts. Okay, now this is the topic where you have to start the question with the test. And you have option now. If you want, you can use ratio test, or if you want, you can use root test. Root test calculations are less as compared to ratio test. Both tests you can use, anyone you can use. But I told you already, I advise you please, if there is no, if there is a factorial involved, don't use a root. Okay? Don't use the root in the factorial case. In factorial question, please use ratio. If there is no factorial, use the root test because the root test is much easier. We get the answer quickly. Okay? So I recommend here root test if there is no factorial case. Right, so I already discussed with you that how to check means it is power series if x involved, so it's very clear it's power series. Then I told you how to check it is centered about what, okay? Now I will explain how to calculate the interval of convergence and how to check the calculate the radius of convergence, please. Now, actually, the power series has three cases, three possible cases. Case number one. Case number one. The two cases, the first two cases, case one, case two, they have fixed formulas. The formulas are fixed. Means if the calculation answer is this one, then this is I and this is R. Okay. First two cases, they have fixed rules, no changes. Oh yes. In third case, we need further calculation to find I and R. Okay. Case number one, please. Okay, as I told you, please, you can start this power series testing with the root test or with the ratio test. Any one of them you can use. Clear? I'm suggesting use which test? Root. Root is much easier. Oh yes, if you have factorial, then you can do the ratio. But mostly we use root. Okay, so look at it. If limit and approaches to infinity. So please, I'm using here root test. And another root, absolute value. If the answer of root test or ratio test, please, if it is equal to 0, equal to what?
0.
So you perform this calculation, means you apply the test, the power series, or ratio test on the power series. Any one of the tests you are applying, is your choice. If the answer is 0, so in this case, the interval of convergence, please, interval of convergence. Interval of convergence. Please, we are using capital I. What are we using? Capital I. It is representing what? Interval of convergence. Okay. So if the answer of this test is 0, so the interval of convergence is all real numbers. What is the interval of convergence? Yeah, it means the series converges on all the x values. Clear?
Yes.
On all x value series, what converge, because this is showing what interval of what convergence. And now we need the second thing, please. It is called radius of convergence. Radius, RADIUS. Radius of convergence, which we say capital R, capital R. Okay, so please help me if the, okay, actually radius, radius means what? How you can see the generally define the radius? Yeah, means half distance, okay? So same like here, this is the interval, how much its length? No, I'm asking, this interval has length how much? Infinity. If you divide the infinity by 2, it is what? So, infinity divided by 2? Of course, infinity, yes, you're right. Okay, so even if you calculate the half of the length of the interval, it's also infinity. So please, in this case, when the ratio test or root test, even you answer how much? 0. So the power series converges for all the x values. Means interval of convergence is this one, all real numbers, and radius is what? Infinity. These are fixed rules, fixed for case one. What is case one? If the calculation answer is 0. Get the idea? Case number 2, please. Case 2. Now, you perform the ratio test or root test, please. A7. I told you I'm using a root test. And the answer is what? Infinity. The second option, second case, okay? If arms is what? Infinity. So please look at here. The interval of convergence. Now it is infinity. So infinity is what? Diverges. So this the power series which is given to you, you perform on that this root test. It is diverges. Diverges everywhere except one point. This is, of course, because the ratio test, root test will give you the answer infinity. It means the series diverges, power series diverges all the real numbers except one point. Masking, what is that point?
Which one?
Zero.
Yeah. What is that point? Where the power series is because I need interval of convergence. I need only that part where power series converge. In this case, everywhere series diverges, but except only one point. So what is that point? Where power series converges? Only one point.
An equals 0.
I'm asking, on which point power series converges? Okay, so that point is basically C. Sure. That, see what I told you say about C? C is what? About which the series is centered. Okay? So in this case, power series diverges everywhere, all that's well, except only one point. And that point is which point? That's why I asked you how to calculate C. Because in this case, our interval of convergence answer is C. Second thing, as we did before, we need radius of the convergence. We half length of the interval. So what is the half length of this interval? It's a length is C.
No, like 0.
Length is length is 0 because this is starting point, this is end point. There is no length. It's not interval that from this point to this point. There's only one number, one number. There's no length. This is starting, this is end.
0.
So starting C, end C, so C minus C, 0. And divide by what?
2.
So basically, there is no length of this. It's not interval. No length. It's one point only. If you have interval, yes, it has a length. For example, let's say you have interval between -5 to 3, for example. So how much length? 3 minus 5. It has length. If I ask you, I need its half length, means radius. So divide by 2. So its R become how much? 4. Here it's not interval, please. Sorry, it's not the 2 point. It's only 1 point. Starting and end, same. No length, 0 length.
So C minus C over
2.
0.
So 0. And that's why in this case, the radius of a convert is 0. So please, these are two cases whose rules are fixed for I and R. The rules are fixed, please. Do you understand these two cases? Case number 3 means when you apply the ratio test or root test, the answer not 0, the answer not infinity, then in that case, how to calculate I and how to calculate R. Okay, so shall we do this one? Okay, so first take some question on the case 1 and case 2. Yeah, please.
Can you go up?
So first we discuss some question on case 1 and case 2, and then inshallah we discuss the case 3 as well. So let me just include some questions from case 1, please. So I put some questions for the reference here. Okay, so please. Now I start some question, please. So I take some example, please. Let's say, yeah.
It's not from the book.
It's not from the book yet because I couldn't find this case 1, case 2 in the book because I don't have time. I just want to break. I check, but I couldn't find. Then I make some myself. Okay. So sigma n is equal to 0 to infinity, please.
So this is case one.
We check, we don't know. We don't know. We have to check. We have to check this. Okay. Right. Now I have question. Number one, is it power series?
Yes.
How it is power series?
X.
Yeah, because X is involved in the question, that's why it is power series. Good. If it is power series, that's when you require two things. You need interval of convergence, you need capital I, and we need radius of convergence, means capital R. Okay. Before to capital I and R, we have to perform a test. I told you, you can use either a ratio test or either you can use root test. So which one you prefer? Yeah, actually factorial one, so ratio test is the best option. Start now, please. You know where the ratio is, huh? Language? N approaches to infinity, a sub n plus 1. So x power n plus 1 divided by n plus 1 factorial. This is my a sub n plus 1 term. Divide by the question. So times flip and factorial divide by x power n. It has absolute value. I just put the value in the ratio test. Why I select ratio test?
Because we have factorial.
Because we have factorial. That's why I told you, don't use root test if you have factorial in your question, okay?
So sir, here we will take x power n times x.
Yeah, we can break now, for the cancellation purpose, we will break now this x power. So limit n approaches to infinity, x n plus 1, I can write x power n times x, right?
Yes.
N plus 1 factorial,
Can make it n factorial.
n plus 1,
And then n times
then n and stop here is factorial. Here I have n factorial divide by x power n with absolute value. What do you think from
Can
here?
cancel n factorial.
This is the basically the ratio test we use here, okay? It's 9.5, if you remember. Ratio and root, okay? 5 pieces. In 9.7, as I told you, it depends your choice. You can use a ratio test, you can use a root test. I suggested use a root test if there is no factorial. If you have factorial, then we have to use the ratio test. Okay. So any cancellation?
Yes.
Cancel out. Cancel out. Okay, good.
So.
Now, look at here. After cancellation in the numerator, what you have?
X.
X, okay, and in denominator?
N plus 1.
N plus 1. Now, please look at here. The limit is on what? On n or on x?
And
It means x has no impact on limit. Because this limit is on n. This portion will affect by the limit. X has no impact on the limit. You can take x outside, interval. X has absolute value. Don't forget x has absolute. X is not constant. It's a function, please. So x absolute value I took outside the limit because this limit has no impact on x. Agreed?
Yes.
It's the limit and approaches to infinity. So what is left over now? 1 over n plus 1. Yes. So if you apply here limits 1 over infinity, it is 0. And 0 time absolute value of x is how much, please? Times 0. So how much? So it is which case? Case 1 or case 2? Case 1. So please, first of all, give us capital I. Absolute, sorry, interval of convergence. Yes. So capital I, how much, please?
Or real numbers, negative.
That infinity to infinity. What is the R?
Infinity.
So R is, and that's it, we get the answer.
So therefore, it's possible that x equals infinity.
Huh?
It's possible that x equals infinity.
X is infinity.
There's a domain.
No, it is interval of convergence and radius of the interval of convergence.
What does this mean?
Means this power series is basically this power series converges everywhere from 0 to infinity. Okay, on x values from all every x values it is converges. Okay, on all the x values it is converges. The first case, okay. Let's take one more question, please. And we check is which case, please. For all real numbers, okay, x is all real numbers. This means that sigma is any values. I'm asking about x, all real numbers. Is converges all real numbers, okay? Minus infinity to infinity. It's the main for x. N is different. And start from 0 to something, right?
Yes.
Okay, one more question. One more question. Sigma n is equal to 0 infinity x raised to power 2n and divide by 2 and factorial. Yes, please. Is it power series? Yes. So for this power series, please calculate I and R. Which test you apply here?
Ratio.
No, please don't apply ratio test. It takes time. There is no factorial. So,
There.
oh, I'm sorry. So, ratio test. Yes, yes. Please check the. Oh, yes. Is this? Is that factorial? So, please someone, we need its answer. What is the output? Is it 0 or infinity? So which case? Maybe third case, which is not 0, not infinity. This is centered about what?
0.
Yeah, this power series is centered about 0, you're right. Anyway, please come on. First of all, apply ratio test here. We want to know.
What will be centered about C? Maybe is centered about C.
About some point, yeah.
0 or C?
0 and C. Here is 0 because when you solve for x, put x equal to 0. So x is 0. There's no point inside x.
Was X minus C.
So yeah, if you get C value, it is centered about that point. Right now, there is no C value. I mean, there's no constant involved here. So x is 0 basically.
Yes.
Yes, please. What's the answer? So if you're applying here the ratio test, so you need the n plus 1 term, okay?
Yes.
So n plus 1 term, we divide the question will flip. Yes, please. What answer?
I didn't get the answer, but if you add 2n plus 2 factorial, can you split it into 2n factorial and then?
No, please. This is the whole factor. Is a complete factor, okay? So you cannot break this up. Means when you replace n, please, it has get at the end factorial. So what is the a sub n plus 1 term? So x 2 times n plus 1, right? And divide by 2 times n plus 1, and it has. Just only replace wherever you have n, replace by n plus 1, please. Okay. So here you can make it 2n and plus 2, right? and divide by this is 2n plus 2, and it has factorial. And if you want, you can take one more step. Break x power 2n times x squared divide by now 2 and plus 2. And so this is my n plus 1 term. I hope all of you have same term. Okay, now divide this by the question. So when you say divide, that will become multiply, it will flip. Okay. Reciprocal, you're right. So let's apply now the ratio test to limit and up to infinity. I'm sorry, so x power 2n times x power 2 divided by 2n plus 2 with factorial divide into multiply. So what happened in the question? 2n factorial will go up, becomes 2n factorial divide by
X to the power of 2n.
x to the power 2n, and it has absolute value. Understand? I just put the value in the formula. Now please, here, yes, this and this is cancelled out. And now you have to please expand this factorial until what? Until 2n. So
2n plus 1.
x squared with respect to n is a constant. Constant means it's a known fact. You can take outside, please. So it becomes now x squared absolute value.
No need because it's.
And yeah, you're right. Good. Actually, x squared absolute value is x squared doesn't require absolute value because x squared is already positive. So if you want, yes, you can. Yeah. Oh, good means actually you have understanding here because the same thing I have in my next topic. Anyway, right. So please, we have now 2 and factorial. Please, come on. How expand 2n plus 2 factorial? So it is 2n plus 2,
Times 2n plus 1
2n plus 1,
times
2n, and stop with factorial. So now you can see this and that gone. No more factors involved. Apply limits on infinity.
1 over this.
1 over infinity, how much? 0. So at the end, the answer how much? 0. Okay, good. What is the I?
From negative infinity to infinity.
This is all real numbers of x. And what is R?
Infinity.
Okay, good. I hope you understand. The first case. Understand?
So these are the points.
Actually, until now, I only discussed with you 2 parts. I and R. Third part, I hold, okay? Please.
It doesn't matter, right? Don't expand it. Because you're gonna multiply the 2 layers. It's better if you don't expand it. So it's easy.
No, actually, right now, in the question, this factorial is basically already 2.
Yeah, but even if you don't consider it, it would be multiplied anyways. And we could multiply them in this would multiply by x. Doesn't make sense.
Yeah, you can, but the thing is that actually,
Does it call?
because 2n, the factorial is with 2n, not only with the n.
Was there, where about n plus?
Yeah, because actually, it is, look at here.
Yeah.
Oh, but the thing is that here, no, look at it. Here, how you can take out 2n plus 1. We have common here too.
No,
Yeah, that's fine.
I'm saying if you don't expand there, later on when you're multiplying, for example, if you multiply 2 with this, and then multiply with this, it would still give you the same value.
But I think it's not, not very correct because this factorial is with the 2 as well. You cannot make it separate from the factorial, okay? Right, please take one more question now. Right now, I'm just, discussing 2 special cases, please. So let's take one more question here. Okay, so one more example, please. Actually, unfortunately, all have factorials. Sigma N is equal to 1 to infinity. This is now n factorial, and then you have 2x minus 1 raised to power n. Okay, come on, please. Is it power series? Yes. So please apply here. Of course, it's factorial mode, so you can apply ratio stress. Okay. Please apply restrictive signals. Yes, what are you getting answer? Please, this topic is, it has 6 mark, okay? So you should be, focused on 9.7. Because I told it has 3 parts, A, B, and C. Part C is very important, but I did not discuss part C because in first 2 cases, we do not discuss parts. Well, the answer is infinity, okay. So if the calculation of your ratio test giving infinity, what is I? How much capital I? I is
C.
I is C value. And what is C here?
Half.
Half. Yes, good. And what is R?
Zero.
R is 0. Yes. So R is 0 and capital I is 1 by. I told the fixed rules.
R is the C over 2. No?
Zero.
I go 0.
Length of the interval. There's no interval in I.
I
Okay? 0 length. So, yes, you're right. It is the calculation of the ratio test means by A sub n plus 1 is n plus 1 factorial 2x minus 1 n plus 1. Okay? Now, this should be divided by the question. Yes. So please, now I'm trying now the ratio test, which is limit n approaches to infinity, a sub n plus 1 divided by a sub, which is n factorial, 2x minus 1 power n with absolute value, please. Now I can break is 2x minus 1 n plus 1. I can break into parts, which is basically
Power n.
2x minus 1 and it's right, please. Okay.
And we can expand n plus 1 factorial.
Okay. Now,
N plus
what
one.
is the cancellation? Okay, we can spread this one.
Yes.
If you don't mind, can I do here, please?
Yes.
So n plus 1 then,
N.
and then
No, I
factorial.
can cancel n with n.
Okay,
And 2x minus 1 to power.
very good. So what is the basically, okay, this
You
one
can take this
is
outside.
2x, okay, it's 2x basically, it's 2x. It is 2x basically. So we can take it
Outside.
outside. So now it is 2x with absolute value, okay? And we have limit n approaches to infinity. We don't have now any denominator. We only have n plus 1 absolute value. If you apply here limit infinity, what's the answer? Okay? So in this case, the power series is diverges everywhere except one point. And what is that point I told you? C. So from here, what is C?
Half.
Solve for x. Solve this part for x. 2x minus 1 is equal to 0. You get x value. So how much x value? 1 by 2.
Yes.
So now capital I is half 1 by 2. So this is no interval. It's only 1 point in the set, please. So what is R?
Zero.
Yes, because there's no length, zero length. Zero length divided by half 2 is 0. Understand? Okay, let's take one more question on this topic. Then we start the question from the book, please. Actually, I just want to finish this two special cases. Okay, now one more. You can please try one more example. Now, n is equal to 0 to infinity. This is n factorial x power n. Please start. N factorial x power n.
But we always use the ratio. The ratio.
Actually, by chance, the example which I quoted here all have factorials. That's why we are using ratio. I will take each other next question from the book. If there is no factorial involved, we use root. Okay? Yeah, I told you means where and when you can use ratio and root case in this 9.7 case. The root is much easier. Root calculation are less. Ratio test calculation are lengthy because we need a sub n sub 1. Then you divide by the question. Okay, so it takes time. Infinity? Okay, good. So if it is infinity answer, what is the I?
Zero.
Very good. R? Yes. Capital I, 0. Because this series is centered about origin. Before is 0. Yeah. So I is 0 and R is 0. Yes, absolutely correct. You are right. Because the answer is infinity. Okay, good. Means if you don't mind, I can write here limit n up to infinity. This is n plus 1 factorial x power n plus 1. I can break, am I right? Divide by the question, which is n factorial and times x power n with absolute value. This I can expand until n. Understand is not this. I explained many times how to expand in factorials. So this cancel. This and that cancel.
You can take out.
X absolute value you can take outside. And here is the absolute value of x. Now limit. And number to infinity, you have now n plus 1 with the same value. And it is infinity, yes. And I told you many times, the second case, rules are fixed. So if the answer of your ratio test or root test is infinity, so in that case, what is I?
C.
I is C. C means the series is centered about what? So this power series is centered about,
Zero.
yes, x 0, exactly. So it is 0. It's 0, okay. And what is R?
Zero.
R is also 0. Understand it here? Good. Let's take the case number 3.
How
Yeah.
did we know that they are centered,
Because in x, in the question, look at it. Can you find any x plus something or minus something? No, so no. Nothing. So x is 0. Okay, it is centered about 0. Now we take some question and we apply root test or ratio test. It depends on the power series, what is given in that power series. Then we check if the answer of the test not 0, not infinity, then how we find I and R. Okay?
There's not.
Good.
Or I.
Not yeah.
Not a.
Okay, now this we got it. Let's start with question number 4. Question 4, we can start this. 3x minus 2 power n divided by n. Okay, so question 4. Question 4 is 9.7, number 4 sigma. is equal to 0 infinity,
X minus 2
3x minus 2
over n.
power n
Yeah, and over.
over n. Okay, good. Now, you can see here, there is no factor involved, so it's better use a root test. Let's take that nth root, okay? Because, okay, is it power series?
Yes.
Yes or no?
Yes.
Yeah, so you can use ratio test, you can root test, but I told you preferable is root test if there is no factor, because root test give you answer very quickly and it's easy. And you don't need any n plus one term. No, just take the 1 by n power of the question. So please, we are applying a root test.
Sir, does it work on the the ratio test?
Yeah, you can try. Yes, yes. Limit. So we have limit n comes to infinity, 3x minus 2, it has n power. Take the nth power, please. Divide by n, take the nth power, n absolute value. So you understand what I did?
Powers are cancelled.
Means I apply the root test. Root test calculate the nth root, 1 by n power of the question. I have numerator, I have denominator. I apply the 1 by n power up as down. Agreed? Very good. What happened here? This is cancelled out.
The denominator is 1.
How much? N power 1 by n with n infinity?
1.
Very good. It's become 1. Good. So what is numerator now you have?
3x minus 2.
Oh, yes, please. 3x minus 2 will affect the limit? Will limit affect the 3 minus 2? No. Take it what? Outside. So please look at it now. Now means as per calculation 3x minus 2 with what?
Absolute.
Yes, with absolute. Don't forget that when you take this out, it is in the absolute value. Understand? Okay, now you have limit and approaches to infinity. So what is now inside? Because this is 1. So nothing is the 1. So the answer is what? 3x minus 2 with the absolute value. Is it case 1?
No.
What is case 1? Yeah, the answer of the calculation is 0. Is case 2?
No.
What's the answer of this? So it is not 0, it is not, so it's not case 1, it is not case 2, it is case number
3.
3. Yeah, my friend, please. So this one, actually, we already discussed in root test. The result of n power 1 by n, when n will infinity, it is 1. Yeah, it is a property. Please, I write again. Limit n goes to infinity, n power 1 by n, it is basically. No, please. This is a property, and we can justify with the local rule. Okay, we have when we did very question in chapter 7.5 when we discussed local rule. So it's a result. Just use it directly. Save time. Okay. So now, please, as I told you, means so limit is on 1 is 1 now, please. So the answer for me is 1. So basically, the root test giving you output 3x minus 2 absolute value. Understand, Mike? The answer is not 0. The answer is not infinity. It's not case 1. It's not case 2. It's case number 3. How deal now case number 3? The requirement is same. Now we need part A, interval of convergence. Okay. We need part B, we need radius of convergence. And part C, we have to check on which x values this power series converges conditionally. Okay. Okay. So please, part A, we need capital I, which is means interval of what? Interval of what? Convergence. Interval of convergence. Okay. Again, I'm telling you, please, focus, please. We need interval of convergence means only that portion where power series converge. Understand? Which test you use, by the way, here? Which test you used? Root. Okay. You know very well, root and ratio, they have same meanings. When the root test or ratio test converge, when? When?
That's the,
When answer is how much?
that's less.
Less than one. This time we are only interested on what? Convergence. So it means, please,
This is this one.
it means this 3x minus 2, 3x minus 2 absolute value must be what?
That's less.
Yes, then you get the convergence. Because ratio test and root test requirement is there. If the ratio test answer or even root test answer is less than 1, it is what? So please, the 3x minus 2 absolute value must be what? Less than 1. Now, it is, okay. This is what? Okay, and what is that?
That's the.
So, this is this topic of algebra. This is which algebra topic? What we call this topic, algebra? Come on. Huh? This is which topic in algebra? Huh? Which inequality?
Absolutely.
It's called absolute value inequalities.
Take 1 to 7.
So do you know how to solve in algebra absolute value inequalities? If of course, then you get the answer of part A in 1 second. So please tell me how to solve.
3x minus 1 is that 1.
Mhm.
Then 3x minus 1 greater than. Minus 2 greater than.
-1 and it's -2 equal 1.
Equal?
This time.
Less than, exactly. You're right. Basically, this is the rules. Absolute value of x, if it is less than k. So it's called absolute value equality. So how we answer it, please? You're right. X greater than negative k and less than positive k. Okay? My key is now here 1. So please remove the absolute value. So how you get 3x minus 2 is less than positive 1, however, greater than negative. I hope you understand.
Take the 2 plus.
No. Just find the x value. Oh, that's it. You get the answer outside. So yes, please. What is next step? I need only x, please.
So take.
Take the outside.
Outside? No.
You outside.
Outside, yeah, please. Add plus 2 here, please. Plus 2 here and plus 2 here. Because I need only x, so this minus is extra for me. I have to cancel it. So how I cancel minus 2? By adding plus 2, yes or no? But if you are doing here, so you have to do all side. So this is gone. So means so this and is gone. I have 3x less than 2 plus 1, 3. And here 2 minus 1.
1.
Okay. I need only x, please.
Sorry?
Yes, divide 3 here, divide 3 here, divide 3 here. It is gone. So please tell me what is my x equal now? Greater than 1 by 3 and less than 1 because it cancel. So what is the interval of convergence?
From 1
1 over 3 to 1. That's it, part A done. My I, capital I, is equal, open or closed?
Open.
Yeah, it's always open, please, okay? 1 by 3 and 1. This is the capital I.
Use it over 3 to make the x alone, yeah?
Exactly, to make the x unknown, because we need only x value. Understand, party? Is that clear? So in all the case study, you have to go like that. You always get absolute value and you expand with the rules which I just told you, okay? So until here is a part A. Now, part B is R, radius of convergence. So radius of convergence. Radius of convergence means a half distance or half length of this interval. So what is the half length of this interval? 1 minus 1 by 3. By the way, I'm using, a shortcut. Actually, it's not the way, but please, it works, okay? It works. That's why I'm using this. In the book is not like that, okay? Anyway, what's the answer?
1/3.
1/3. This is your radius of half length of this interval of convergence. Until here, any question?
How did you get this rule? It's this rule.
This one? This length, 1 minus 1/3
And divide
divided by 2. Means the length of this interval, 1 minus 1/3, you get the length. We need half, radius means half. So divide by 2. So until here, any question, please, any doubt? So 2 marks up, 2 marks down, you get 4 marks. Right now, you got 4 marks out of 6, okay? Now part C. Part C, please get focused. Please, huh? Part C, look at here. First of all, I write the question of part C. Then before I answer part C, I explain the rules first of all. I not answer directly. First, I write the question. What is part C, please? Please, just focus. In part C, what they're asking from you. For what value of X series converges how? Converges how? Conditionally. Yes. This is the question. This is part C, please. For what value of X series converges conditionally? Okay. Now, please, if you look at the part A, please, part A. Look at part A, I value. Can you just tell me this I value is telling you what?
Positive.
Huh?
Positive.
This I is what? Interval of? Means from where to where series? So please tell me, what is any, you can say, ambiguity or something which is not clear here? What is that? So,
Yeah.
basically, this capital I is representing interval of convergence. This is that portion where power series converge. So between 1/3 to 1 on all its points series is converges without any doubt. We have doubt on 2 points. Which points?
1/3 and
1/3, and because they are not closed. It's not the case that from 1/3 until 1 it is converged. No, it's open. We say between 1/3 to 1. We have no information on 1/3 series converge or diverge, we don't know. At 1 series converge or diverge, we don't know. So basically, it's very clear when they're asking from you, for what value of X series converges conditionally, actually they are talking about only 2 points. Which points? 1 or 3 and 1, because they are not clear. Between them is very clear, because this I is representing you that between 1/3 to 1, if there are infinite points between 1/3 to 1, how many points? Infinite, you can count. Power series converges without any doubt, because it is interval of convergence. You understand point? Except 2 points, we don't know about that. So this doubt we have to clear now. So first we check which point? 1/3, and then we check which point?
1.
Yeah, so basically you have to check now 1 by 1 that at 1/3, what is the power series behavior? Converge or? And then we check at 1, what is the power series behavior? Converge or? Okay, now one more question. For example, in part C, we check, of course, 1/3. If 1/3, becomes converges, what change in the interval?
Closed.
Oh, yes. For example, when you make calculation and you got that 1/3 on 1/3 series converges, you go back to part A and make it what?
Closed.
Oh, yes, be closed. Don't forget this point.
The same thing goes for.
Oh, yes, same thing goes for 1. For example, when you check 1 and it comes to you the calculation that at 1 also power series convert, so make it what? If both are not converges, so it remains like that. Yes, open. Do you understand the logic? Okay. Now I will tell you how to check conditionally converge. Means when we say the series converges conditionally, okay? So please, for this purpose, let me explain in the detail, please. So first of all, please, because our target is conditionally converges, okay? Converges conditionally. So what is the rule? When you say a series, a power series converges conditionally, please, okay? So with which calculations we perform? Okay, so please look at here, please. Before I ask the question, first I give the the rules of conditionally converges. For okay, I'll just make a separate space for you so that I can explain to you what is meant by conditionally converges. Now look at it, please. If if absolute value of the series, which value? Absolute. If absolute value of series diverges, absolute value what? Diverges. And without absolute value converges. Then series converges conditionally. This is called conditionally converge condition. Then series converges conditionally. So basically, you have to check these two things. First of all, make the absolute value of your question which is given to you and check the behavior. If it is diverges, then remove the absolute value and check the behavior. Without absolute converges, then you say it is conditionally converged. So you have to perform two calculations, please. One calculation with absolute value and second calculation without absolute value. So this is the procedure for part C. Understand the procedure? Okay, and we have how many points to check? Two. So one by one, we start. Okay. So what is first point to check, please? 1/3. Good. So let's check, please. First of all, please. I told you already. Only the boundary points have doubt. We don't know about that. That 1/3 behavior and one behavior is what. Okay. So let's start with 1/3. So now the first point which we are using now when x is equal to 1/3. Go back to the question, please. Question, because we have checked series, series converges on 1/3, yes or no, okay? So please, this is your question. 3x minus 2 power and divide by n. This is my question. 3x minus 2, please. My question is sigma 3x minus 2 divided by n divided what? N, okay. 0 infinity. Okay, now, x value how much? X value how much, please? Please put here 1/3, please. Okay, for conditionally converges, first calculation with what? With what? Okay, so first of all, we will check this basically behavior with absolute value. Okay, x value how much? Come on, please. Put here 1/3. So how much you get? 3 times 1/3 minus 2. It has power n divided by n, and we are using absolute value.
-1
3 cancel out. 1 minus 2, how much? -1. Okay, so I have now this -1 power how much? N divide by n with what? With what? With absolute value. Okay. Now, please, this is my series basically sigma. This n is equal to infinity. Okay. Right. Now, please do one more thing, please, here. Minus 1 power n. When you put some values of here n, what you get, by the way? If I put n here 0,
One.
wow, good. When I put 1 here,
Negative.
if I put here
Negative
now 1,
Negative one.
negative 2, or 3,
Negative
Okay.
one.
be careful. Minus 1 power n has what? Absolute. So please tell me the numerator answer is
Positive.
always
Positive.
okay. So it means you can basically you can look at here. Now look at it, please. Minus 1 power n has absolute value, and n also has what? And sigma is from where to where? 0 to.
Infinity.
Okay, please tell me. Numerator answer is what? Positive. So basically, I always get in numerator what?
One.
Very good. Divide by, please. Divide by. I have now denominator, please. Denominator. And value from where to where? Tell me.
Zero.
0 to
All
infinity.
positive.
And always positive.
Yes.
Because my n is from where to where? 0 to infinity. Do you need absolute value?
No.
Okay, so you can remove it and you have sigma. N is equal to 0 to infinity. After this concept, you are here, right?
Yes.
This is which series and tell me is about it decision.
G.
It's what?
G.
Come on, it's not G, please. The series? P series. Yes.
Equals to one.
And n power something. How much n power here?
One.
If P value is 1,
Divergence.
value. So basically the P series and with that diverges. So now go back, look at here. When you check with absolute value, what's the answer? What's the answer? Diverges. Now we check same thing without absolute value. Don't panic. Don't do any new calculation. No need for anything, please. Just go back here. Here you apply what?
Absolute.
Please, just, do one thing, please. Okay, I don't want to confuse you, so let me write again the same thing, please, but without absolute, okay? Sorry, somebody asked the question. Yes, please. With? Yeah, first of all, we are doing with 1 by 3. First we check 1 by 3, please, okay? Now, please, don't do anything, please. Look at here. Now, second calculation as per the rule, please, let me show again the rule. First, with absolute value, you have to check. And are we getting averages? Then we perform next step, please. So, with absolute value, it averages, yes or no? Now, remove the absolute value and check. So, look at it, please. I told you, don't do any calculation. No, please, no. Look at here, please. Just remove it. Just remove it. Now, try to understand. This is which series?
Geometrics.
No. Huh? No, please don't. Yes, so just forget this now. Okay, only check this one. This is which series? Come on. Huh? Alternating series, yes. Which series? How do you know? Oh, yes, this has sign controller, 9.6, we just finished. This is alternating series, and now we have to check this series converge or diverge, yes. Oh, using ASD, yes, alternating series test, 9.6. So please start now. So again, please, okay, please look at here. First, we check with absolute. With absolute value, we have come to know it is what? Now, second calculation without absolute. So please, same thing here. I just remove please the absolute values. So my series looks like this one. Focus, which is which series? And yes, you told me very correct. It is alternating series. We know very well you can apply this test.
Yes.
Alternating series test. Yes. So what are the two conditions?
Limits of.
Number one, limit and approaches to infinity on which part? On which part?
What?
We do not consider in the calculation the sign control. Understand?
Yes.
What is the answer?
Equals to 0.
Very good. First we justify. Okay. How to check the second condition?
Decreasing by.
By
Plus the.
first derivative. Okay. Now I make it life easy. Here in the 9.7, when you check the second condition of ASD, where we need first derivative, don't use first derivative because already question lengthy. If you go for first derivative test, it takes time.
Yeah.
I will tell you a shortcut how to check decreasing. Okay, but don't use the shortcut in integral test and in ASD. Okay, this only I am giving you advantage in 9.7 question because it has three parts. It's already lengthy, so don't use first derivative test here. Okay, because it takes time. Okay, please. So for the decreasing part, please, for decreasing part, this shortcut. What is that shortcut? The shortcut is that just check. Here this means this is my sequence which I have to use. Is the next value less than previous?
Yes.
Start with 0. Sorry. So then put 0, then put 1. For example, I put 0 here. So sorry, I think it's not 0 basically. So because 0 becomes undefined. Okay, okay. 1,
1.
then 2.
0.1.
Okay, then 3, then 4, then 5. Please tell me, is next value less than previous?
Yes.
Sure.
Decreasing. Yes.
So this is the.
Yellow, we will use this.
No, you use other tests, you don't get it marked. So two conditions justify of ASD. What does it mean? What does it mean? What's the it is what? Converges. So without a value, it is what? It is what? Okay, good. Without absolute value, it is converges. Okay. Now look at here. With absolute value was answer. Diverse. And without absolute value. So what? So at 1, what do you say? Sorry, 1/3. At 1/3 was the answer? Converges conditionally. It is converges conditionally. Yes.
So what about the interval?
Oh, wait. We change, of course. So please, this is the definition of conditionally converge. With absolute value diverge. Without absolute converge, it means converges conditionally. So one thing is confirmed. And when x is 1/3, power series converges conditionally. Done? So go back to your part A. So what happened with 1/3? This 1/3 is now what? Closed. Because as per our calculation, with absolute value series diverge, without absolute value series converge. So please write here. At x to the 1/3, series converges conditionally. Converges conditionally. CONDITI.
Doctor, what about 1?
Yes, now check 1.
What?
Oh, yes. Now, what's the second point to check? Second point? 1. Okay, now, repeat same procedure. Now, please, when x equal to how much?
Look at this for 2 months.
Yeah. No. When x is 1, so what happened? Sigma, what's the question? 3x minus 2?
Yes.
Okay, so 3 times 1 minus 2 power n over n first time with absolute value. Agree? Same thing now with the second point, which is 1, okay? So please tell me, 3 times 1,
1.
3 minus 2.
1.
Okay, good. Look at it now. 1 power n divided by n with absolute value, and it is sigma, of course. Okay, no need to write sigma again. Don't write. Don't worry. Okay. Do you know what is 1 power n?
Yes, one.
Yes, 1 power n is 1. But not minus 1 power n is 1. No, 1 power n is how much, please?
One.
Oh, very good. So it's 1. And 1 absolute value?
And positive.
No. 1 power n is 1. Absolute value of 1? 1. Good. And in the denominator, you have n. And from where to where?
Positive.
From positive. So no need for the absolute value.
One over.
So I get what?
One over n.
1 over n. Right. I get 1 over n. This is which series and give me the decision.
Alternative series.
Come on, please, 1 by n. P series, P is 1, so. Huh?
Right.
P.
Yeah.
One, that's one.
Equals to one, I think.
Equal to one.
That one. P. P is, if P is less or equal to 1, that one is. So please, with absolute value was answer. Okay, now, what is next thing? Without. Please, again, I told you, equal. Okay, now please look at here. First time with absolute value. Answer what? In the same thing, please. Now just remove the absolute value, please. And tell me, is there any difference coming up? Without absolute value, it is also what? Oh, yeah. So with absolute value diverges, without absolute diverges, is it, sorry, is it satisfying conditional version? No.
So keep it open.
Yes. So at 1, it is not converges conditionally, no. So keep your one side open. So please, you can write now. At x is equal to 1, series does not converge conditionally, does not converge conditionally. No way. No way. Oh, so only you have I in that form. Do you know this interval is called which interval? One side open, one side closed. What we say is this interval? Huh? No. See, we have 3 intervals: open, closed, and half open. What we say? Half, not half, okay? Yeah. Half open. So basically, in our answer, in I, basically we are getting half open interval.
Now, sir, what's the final answer?
That's it, we get the answer. You get 6 marks. So, yeah. Okay, so you get all 3 parts correctly, you get 6 marks.
So these
Two
ones,
like that.
just to write whether it's open or closed.
No, please, you have 3 steps. I'm sorry, three parts. Part A, look at the part A. Part A, you get this one, okay? So you get 2 marks. Part B, radius 2 marks. And part C, conditionally converges 2 marks. So 6 marks you got in this question. Understand? So please, basically you have to check that when I'm making the absolute value, which series I'm getting. So basically now, look at here. You are getting the reference of, you should know about G series, its properties, P series, its properties, alternating series, how to check, okay? Actually, there are some question where you have to check by ratio test and root test also, okay? Okay, so it depends when you make the absolute value or without absolute value. So how to check the series basically, yeah? It is converge or diverge. This is the basically all story, yeah? But you understand the bottom line, how to perform this question?
Yes.
Well, okay, that's it. So inshallah, we have last class. And we will continue. Only 1 second left, but I will take more question on this topic.